This video today is going to be on rectangles, so make sure you have your rectangle characteristic sheet out, and you want to write these properties down on that sheet just so you have it as a reference. So a rectangle is a parallelogram with 4 right angles. That's its key characteristic. And there are a list of properties that all rectangles will have. The 2 in that blue color are the new properties that we will see. The rest are all actually repeats of parallelograms. So rectangles will always have 4 right angles, and the diagonals will be congruent. So those are our 2 new properties. The rest of the properties, like I just said, these should seem familiar because they are all the characteristics of a parallelogram. So opposite sides will be parallel and congruent, opposite angles will be congruent, consecutive angles will be supplementary, and then the diagonals will bisect each other. So even though they are the rules from parallelograms, you still want to go ahead and put them on the rectangle sheet. And what we're going to do is use these new rules to help us solve for pieces of rectangles. So we've got our first example here. It says quadrilateral JKLM is a rectangle, and it says if the measure of angle KJL is 2x plus 4 and the measure of JLK is 7x plus 5, they want you to solve for x. So the easiest thing to do is first take the equations that are given to you and put them in your picture. That way you know where they're located. So angle KJL, if I use a highlighter here, we start at K and then go to J and then to L. So the angle that we just drew on is this angle in the corner here. So we'll put that equation is 2x plus 4. So that's for this particular angle. And then it says angle JLK. So if I look at angle JLK with a highlighter, so start at J, L, and K. So this one is specifically talking about this bottom angle here. So this angle is 7x plus 5. So we need to know what we can do to set up an equation. There's a couple different approaches. The first would be that we know that triangle JKL is a 180-degree triangle, so you could use all 3 of those angles to set up an equation. Or, because we know this is a rectangle, and we know opposite sides are parallel, that means that this angle in the bottom here will be the same as this angle here. And the reason is because they're alternate interior. So we know that 7x plus 5 goes here. And we know with it being a rectangle, all angles in a rectangle are equal to 90 degrees. So this angle J is all 90 degrees, which means we can write an equation using both of our formulas here. 7x plus 5 plus 2x plus 4 would have to total to 90. So there is more than one way to approach this problem. This would be the ideal with using the rectangle rules. So then we can go ahead and start solving. So we get 9x plus 9 equals 90. Subtract 9, we get 9x is equal to 81. And then divide, and we get that x is equal to 9. So now we were done. If they asked you to find the specific angle measures, you could obviously plug those back in. Just be careful that you pay attention to what it's looking for. The last example of this video is using our grid. So here it says PQRS is a quadrilateral, which means it has 4 sides, and I tell you each of the 4 corners. So we're going to go ahead and plot these on our grid. So here's P. Let's see, Q is at 1, -1. R is at -1, -4, and then -7, 0. So there's S. So we could go ahead and connect these to make our 4-sided figure. And it wants to know if the shape is a rectangle. So there's a couple different things you can look at. If it says to use the distance formula, then you need to calculate the side lengths as well as the diagonals, okay? Because in a rectangle, we know that the diagonals have to be congruent. But the other thing is you have to make sure it's a parallelogram first. If it's not a parallelogram, then it definitely can't be a rectangle. And the easiest approach is to look at the slopes. So if we look at our slope from S to P, we know it goes up 1, 2, 3, and over 2. So our slope is 3/2, so that's from S, P. If I do the same thing from R to Q, I go up 3 over 2. So from R to Q is also 3 over 2. That means these are parallel. And then I can do the same thing for the other two sides. So from P to Q, I go up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. So my slope here would be up 4 over left 6, so that reduces to negative 2/3. And I would check the same thing from R to S. So up 1, 2, 3, 4, and then up over 1, 2, 3, 4, 5, 6. So RS also has the same slope of negative 2/3. So because my sides are both parallel, that means that it is a parallelogram. And now to determine if it's a rectangle, we can calculate the distance of the diagonals, or we could see if our slopes are perpendicular. So remember, 90-degree angles are formed by two perpendicular lines. So if my two slopes form right angles, then my slopes will be opposite reciprocals. So perpendicular slopes are opposite reciprocals. We talked about that in our previous units. So if I know that one slope is 3/2, the other one was negative 2/3, they are flipped and perpendicular, so that would be good. Okay, and it works for both sets of sides, so because both pairs are perpendicular, we know it is a rectangle. The other thing you could check is to find the diagonals, so use the distance formula and find the length of PR and the length of SQ. And if those two lengths are the same, then it would be also a rectangle. So multiple ways to do this. Just make sure you're using some of those rules that we've talked about in order to prove that they are rectangle. And that's it for rectangles. The next video will be over squares and rhombi.